Ancient myths are being decoded by modern telescopes. Long before we had equations, humanity looked up and told stories about where it all came from. And it turns out many of those stories were startlingly close to the truth. Carl Sagan once said that we are a way for the cosmos to know itself. This journey uncovers 24 ancient theories of cosmic origins, from the Hindu vision of a breathing universe to the Greek idea of atoms dancing in the void, and reveals how cutting-edge science is confirming them today. You will discover how our ancestors' intuition mapped out realities that physics is only now proving. How did ancient cultures know about cosmic cycles we can just barely measure? What does a Babylonian sea goddess have to do with the Big Bang? By the end, your understanding of the universe and our place in it will be fundamentally transformed. What part of the cosmos feels most mysterious to you? This rhythm of cosmic breathing, described in Hindu texts thousands of years ago, presents a universe in perpetual motion, not as a single explosive beginning, but as an endless cycle of expansion and contraction. Each great breath, known as a kalpa, spans an almost unimaginable duration, a single day in the life of the creator god Brahma. Within this framework, worlds are born, evolve, and are dissolved, only to be reborn again in a new form, a process repeating across eternity. It is a vision that profoundly challenges the linear timeline we often take for granted, where history marches in one direction from a definitive start. Here, time itself is cyclical, a wheel turning through ages of creation and repose. The poetic grandeur of this idea of a cosmos that breathes found an echo in the work of a Nobel Prize-winning physicist, Roger Penrose. His theory of conformal cyclic cosmology proposes that our universe is not the first and only one, but merely one in a long series of eons. In this model, the distant, heat-death future of our expanding universe can mathematically transform into the high-energy, low-entropy Big Bang of the next. The evidence for this is subtle, written in the faintest whispers of the cosmos. Observations from the Planck satellite mapping the cosmic microwave background, the leftover heat from the Big Bang, have revealed mysterious circular patterns. Some scientists, including Penrose, interpret these as gravitational wave imprints, cosmic bruises left by the collisions of supermassive black holes from a previous eon. These are the echoes of a universe that existed before our own. Another model, the Big Bounce, similarly suggests an endless cycle where a collapsing universe rebounds into a new expansion, avoiding a true singularity. This convergence of ancient intuition and modern theoretical physics forces a fundamental question. What if our entire cosmic history, from the first stars to the rise of civilizations, is just one phase in an infinite loop? The idea that everything we know has happened before and will happen again redefines our place in the cosmos, not as a unique event, but as part of an eternal, repeating pattern. From that eternal cycle of cosmic breath, we shift to a radically different vision, one born not from divine rhythm but from pure reason. The Greek philosophers Democritus and Leucippus stared into the night sky and saw not gods but geometry. They proposed a universe of utter simplicity, built from tiny, indivisible particles they called atoms, all swirling in an infinite and absolute void. This was a creation story stripped of supernatural will, where everything from a star to a human soul emerged from the random motion and chance combinations of these fundamental bits of matter. Their follower Epicurus would later cement this idea with a powerful principle: nothing is created out of nothing. If something exists, it must have come from something else, a universe governed entirely by natural, comprehensible laws. For over 2 millennia, this seemed like a brilliant but abstract guess. Then we developed the tools to look closer. Modern quantum field theory reveals that the vacuum of space is not the passive, empty void the Greeks imagined. It is a seething, bubbling sea of energy. So-called virtual particles constantly pop into and out of existence, borrowing energy from the void for fleeting moments before annihilating each other. This isn't just a mathematical quirk. Physicists like Lawrence Krauss have seriously explored how such a quantum fluctuation could, under the right conditions, inflate into an entire universe. The empty void, it turns out, is pregnant with potential. We can even witness echoes of this ancient atomic dance today. Inside the Large Hadron Collider, the world's most powerful particle accelerator, scientists collide protons at nearly the speed of light. In the fiery debris of these collisions, they observe new particles flashing into being, a direct, observable testament to the idea that matter can spontaneously generate from energy. The Greek concept of the atomic swerve, an unpredictable movement that allowed for free will and change, finds its modern counterpart in quantum indeterminacy, the inherent randomness at the heart of all physical laws. This raises a staggering possibility. What if our entire cosmos is just one fortunate bubble in an endless, frothing quantum foam, a single universe born from a random swerve in an infinite void? This idea of spontaneous generation from a primal state leads us directly to another profound ancient symbol, the cosmic egg. That cosmic egg, an image of perfect potential, appears in creation myths across the globe, from the Polynesian world egg of Tangaroa to the Chinese myth of Pangu. But one of the most detailed and poignant versions comes from the Orphic mystery traditions of ancient Greece. They envisioned the beginning as a single, silver egg, laid by the serpentine god Kronos in the dark womb of the primordial goddess Nyx. From this egg emerged Phanes, a radiant deity of light, often depicted with wings of gold. His very first act was to bring order to the surrounding chaos, separating light from darkness and setting the cosmic cycles in motion. This was not just a story of birth, it was a profound symbol of unity, a single source from which all the complexity and diversity of the cosmos would unfurl. The egg was everything contained in a state of infinite possibility. It is a vision that feels intuitively, stunningly correct. Centuries later, a Belgian priest and physicist named Georges Lemaitre would propose a radical idea. He suggested the universe began as a single, hot, dense primeval atom, a state of near-infinite density from which everything expanded. His theory, which a skeptical Fred Hoyle would later mock by calling it the Big Bang, has become the cornerstone of modern cosmology. That initial state, the singularity, is our scientific cosmic egg, a point of infinite potential where all the laws of physics as we know them break down. Stephen Hawking's work on the origin of the universe grappled with this imperfect beginning, noting that any theory of creation must account for the flaws and asymmetries that allowed galaxies to form. The cosmic egg, too, had to crack. The evidence for our own cosmic egg's explosive opening is written across the sky. The cosmic microwave background radiation is the afterglow of that initial expansion, a baby picture of the universe when it was just 380,000 years old. This faint, almost uniform whisper of heat is not perfectly smooth. It contains tiny fluctuations, the seeds from which all the vast structures of the universe, the galaxies and clusters, would eventually grow. These are the first cracks in the shell, the initial imperfections that allowed for everything that followed. both narratives, the ancient symbolic and the modern scientific, confront the same fundamental mystery. How does a universe of boundless complexity and beauty emerge from a state of utter unity and simplicity? Whether it is the radiant phanes bringing light or the inflationary epoch expanding space itself faster than light, the story is one of transformation, of potential becoming reality. This leads us to a deeper question. If the universe was born from such a coherent, singular beginning, could it possess a kind of inherent consciousness, a mind of its own? Deep within the ancient Chinese text known as the Sanwu Liji lies the story of Pangu, a cosmic giant who did not merely shape the world but became it. For 18,000 years he grew, each day stretching the heavens 10 feet higher and the earth 10 feet thicker, his very body transforming into the fabric of reality. His breath became the wind and his voice the rolling thunder. His left eye soared into the sun, his right eye cooled into the moon, and the stars themselves were born from the hairs on his skin. This is not just a story of creation, but a story of expansion, a universe literally unfolding from a single, living entity. The myth captures a profound truth about our cosmos that modern science has only recently confirmed. The universe is not static, it is growing. In the 1920s, Edwin Hubble made the landmark observation that distant galaxies are all rushing away from us, their light stretched into redder wavelengths, revealing a cosmos in a state of constant, relentless expansion. The rate of this growth is measured by the Hubble constant, a number that quantifies how fast the universe is stretching itself apart. This isn't a simple explosion from a central point, but an expansion of space itself, carrying galaxies along with it, much like the parts of Pangu's body growing and separating as he stretched. The structures we see in the cosmos today echo this anatomical metaphor. Vast surveys of the night sky reveal that galaxies are not scattered randomly. They are arranged in an immense cosmic web, with long, thin filaments of galaxies connecting at dense nodes, a structure that looks eerily like a neural network or a system of veins and arteries. These are the giant's limbs, the large-scale anatomy of our universe, traced in light. Cosmologist Brian Greene has pointed to the poetic resonance between these modern discoveries and the ancient intuition of a living, growing cosmos. The force driving this expansion into its current accelerating phase, a mysterious presence we call dark energy, acts like the relentless life force of Pangu, ensuring the cosmic body continues to grow. This vision from the 3rd century offers a deeply intuitive grasp of a concept that is mathematically complex. We are not just living in a universe, we are living inside the unfolding body of a cosmic giant, a reality born from a story told millennia ago. And just as life emerged from the waters that flowed from Pangu's body, so too do many of the world's oldest creation stories begin with a primordial, chaotic sea. Long before Marduk raised his storm chariot, there was only Tiamat, the roiling, saltwater abyss from which all things would be born. In the Babylonian epic known as the Enuma Elish, the universe begins not with light or land, but with this liquid chaos, a primal ocean personified as a mother goddess. The story tells of a cosmic rebellion where the younger god Marduk confronts and slays Tiamat, then performs an act of profound creation from her destruction. He splits her carcass like a clamshell, using one half to fashion the dome of the heavens and the other to anchor the solid earth. Her weeping eyes become the sources of the Tigris and Euphrates rivers, her snarling teeth the mountains, and her swirling insides the storms. This is a creation narrative built not on gentle formation, but on a violent struggle where order is carved directly from the body of chaos. It is a theme that resonates with a startling, almost unsettling clarity in modern cosmology. Scientists now describe the earliest moments of our universe not as serene emptiness, but as a seething, opaque plasma, a hot, dense primordial soup of fundamental particles. In this state, matter and energy were so intensely coupled that light could not travel freely, rendering the cosmos a churning, fluid-like entity. Some models of cosmic inflation even suggest the universe expanded with characteristics similar to a fluid, flowing and smoothing itself out in its first fleeting instance. The act of Marduk dividing Tiamat's body finds a powerful parallel in the subsequent cooling and separation of the fundamental forces of nature. Just as the sky was forcibly parted from the earth in the myth, gravity split off from the electromagnetic and nuclear forces, a process that allowed for the stable structures of our universe to eventually form. Even the water motif holds a profound scientific truth. The most abundant elements forged in the Big Bang were hydrogen and helium, the very components of water. All the water on our planet and in our bodies was ultimately created in the nuclear furnaces of ancient stars, born from those stellar waters. This is cosmic nucleosynthesis, the alchemy that transformed a simple, chaotic sea of particles into the complex elements of life. The violence of Tiamat's end mirrors the violent beginnings we now understand shaped our cosmos, from the explosive births of stars to the collisions of galaxies. These ancient stories provide a narrative framework for comprehending the immense, impersonal forces that forged our reality. They ask us to consider whether the universe we perceive as orderly and structured is, at its heart, still a manifestation of that original creative chaos. This leads us to wonder if that underlying chaos is in fact governed by a deeper, hidden order, a perfect mathematical design. The idea of a universe born from violent chaos gives way to an ancient vision of perfect, silent harmony. Pythagoras and his followers in ancient Greece listened to the world and heard music. They believed the planets themselves moved in perfect mathematical ratios, their orbits tracing circles in the sky that corresponded to the intervals of a divine scale. Each celestial body, from the Moon to Saturn, was thought to emit a unique, ethereal tone based on its speed and distance, creating a cosmic symphony inaudible to human ears, the music of the spheres. For them, mathematics was not just a tool for calculation, it was the hidden language of reality, a sacred geometry that governed everything from the motion of stars to the very essence of the soul. This was not a metaphor, but a foundational principle that the universe was built from number and vibration. The modern incarnation of this idea is found in one of physics' most ambitious frameworks, string theory. It proposes that at the most fundamental level, reality is not composed of point-like particles, but of unimaginably tiny, vibrating loops of energy. Each distinct vibration of these strings corresponds to a different fundamental particle, like an electron or a quark. The physicist Michio Kaku famously described this by saying the universe is a symphony of vibrating strings, a direct and stunning echo of the Pythagorean dream. We can even hear the remnants of this primordial music. When the LIGO observatory detected gravitational waves, ripples in the fabric of space-time caused by the collision of two black holes, the signal was translated into sound, a clear, rising chirp. This was not just data, it was a cosmic event singing its story. Furthermore, the faint afterglow of the Big Bang, the cosmic microwave background, contains imprints of oscillations, pressure waves that sloshed through the early universe like sound waves in a vast chamber. These oscillations ultimately dictated where galaxies would form, meaning the large-scale structure of everything we see was seeded by primordial vibrations. Even the orbital resonances in our own solar system, where the orbits of moons and planets lock into simple integer ratios, reflect that ancient mathematical order. So, could the cosmos be fundamentally musical? The Pythagorean intuition suggests that the deepest truths of existence may not be found in silent equations alone, but in a kind of harmony, a resonant order that underlies all apparent chaos. This profound sense of a balanced mathematical universe naturally leads us to consider the primal ingredients that such a harmony organizes, the fundamental elements themselves. Before the first pyramid cast its shadow, Egyptian priests in the city of Hermopolis described a beginning not of gods, but of fundamental principles. Their creation story revolved around the Ogdoad, four pairs of primordial deities who were not people, but personified forces of chaos. There was Nun and Nonet, representing the infinite, chaotic waters. Kuk and Kokit embodied the endless darkness. Heh and Horhit were infinity itself, while Ammon and Ammonet symbolized the hidden nature of the air. These 8 beings existed in a swirling, undifferentiated state, a cosmic soup where all potential was mixed together. From this turbulent unity, a single event sparked creation, the emergence of a primeval mound, the first solid land rising from the formless waters. This was the moment chaos began to crystallize into order. The Ogdoad structure is strikingly modern. Each force is defined by its opposite, a male and female pair existing in perfect balance. This mirrors one of physics' most fundamental discoveries, particle-antiparticle duality. For every particle of matter, there exists a corresponding antiparticle, an opposite with the same mass but opposite charge. They are cosmic pairs born together from energy, and if they meet, they annihilate each other in a flash of light, returning to the formless void from which they came. This is the quantum vacuum, not a true emptiness, but a seething potential where such pairs constantly flicker in and out of existence. The Ogdoad state of chaotic potential is a powerful metaphor for this quantum realm, the symmetrical state from which our asymmetric universe somehow emerged. The emergence of the primeval mound finds its direct parallel in the theory of cosmic inflation. In the first fleeting fraction of a second, the universe underwent a phenomenal growth spurt, smoothing out the initial chaos and amplifying tiny quantum fluctuations. These minuscule ripples, these primordial mounds of slightly denser energy, became the seeds for all future structure. As cosmologist Lisa Randall's work on extra dimensions suggests, the properties of this early universe, its very laws, may have been shaped by realities we cannot directly perceive, much like the hidden nature of Ammon. The first galaxies did not form randomly. They coalesced around those initial density fluctuations, the cosmic mounds that grew over billions of years into the vast web of stars we see today. So what can these ancient Egyptian pairs teach us? They offer an intuitive grasp of a universe built on balance and symmetry, where creation is the process of breaking that perfect symmetry to build a world of rich complexity and form. This profound sense of a reality emerging from numerical principles leads us directly to a different kind of number, one that defines beauty itself. That same sense of a universe built on hidden structures finds a breathtakingly literal form in the ancient Mayan vision of the world tree. For the Maya, the cosmos was not a random scattering of stars, but a living, breathing entity held together by a great axis, a colossal ceiba tree with its roots deep in the dark underworld of Xibalba and its branches reaching into the highest heavens. This was the axis mundi, the central pole that connected all realms of existence, from the subterranean waters to the celestial realms of the gods. It provided a sacred geometry to the universe, a map of spiritual and physical interconnectivity described in their creation epic, the Popol Vuh. This was not merely a symbol, it was the fundamental architecture of reality. Today, when cosmologists map the observable universe on the largest scales, they find that same branching structure etched across the cosmos. The Sloan Digital Sky Survey has revealed that galaxies are not evenly distributed. Instead, they cluster along immense, thread-like filaments of dark matter, forming a vast cosmic web that stretches for billions of light years. These filaments intersect at dense nodes where enormous galaxy clusters reside, while leaving behind vast, empty voids. The resemblance to a colossal, three-dimensional tree is uncanny, with the dark matter acting as the unseen roots and trunk that give shape to the entire structure. The pioneering work of astronomer Vera Rubin provided the first compelling evidence for this hidden framework. Her observations of galaxy rotation curves proved that stars at the edges of galaxies were moving far too quickly to be held in place by the gravity of visible matter alone. Something unseen and massive, what we now call dark matter, must be providing the gravitational scaffolding. This dark matter forms a halo, a kind of root system, that guides the formation and motion of the luminous galaxies we can see. Just as the Mayans aligned their sacred trees with the celestial poles, giving order to the heavens, this cosmic web provides the underlying lattice upon which the entire visible universe is woven. The metaphor is so powerful it forces a profound question. Are we living inside a cosmic tree whose branches are made of galaxies? This ancient intuition of a connected, living cosmos provides a deeply human way to comprehend the cold, hard data of modern astrophysics. It suggests that the universe possesses not just a structure but an anatomy, a form that echoes the most fundamental patterns of growth found right here on Earth. This sense of an ordered, living cosmos naturally leads us to wonder about the rhythms that govern its long-term existence, the great cycles of time that dictate its ultimate fate. The Norse vision of the cosmos was not a single universe, but a multiverse held together by a suffering giant. Yggdrasil, the world tree, is an immense ash whose branches hold the 9 distinct realms, from the divine Asgard to our own human world of Midgard. This is not a static structure. The Eddic poems describe a living, dynamic entity constantly under assault. A great serpent Nidhogg gnaws at its roots, while a stag feeds on its leaves, and the entire tree trembles, awaiting the cataclysm of Ragnarok. Yet from this destruction, a new and fertile world is prophesied to emerge, green and beautiful from the sea. This is a cosmology built on interconnected struggle and cyclical renewal, where different realities coexist on the same cosmic scaffold. The modern scientific counterpart to this ancient tree is the inflationary multiverse. According to this theory, the rapid expansion of space in our universe's first moments was not a unique event. Eternal inflation suggests that new pocket universes are constantly bubbling into existence within a greater, ever-expanding meta-universe. Our entire cosmos, with its own distinct laws of physics, could be just one such bubble among an infinite number, each a separate world on a branching cosmic tree. Physicist Max Tegmark's classification of multiverse levels finds a startling parallel in Yggdrasil's structure. His Level 1 multiverse, regions of space so distant we can never see them, could be other branches on our same limb. His Level 3 multiverse, born from the many worlds interpretation of quantum mechanics, suggests that every possible outcome of a quantum event actually occurs, spawning endless branching realities that coexist alongside our own. These are the myriad worlds of the tree, all real, all unfolding simultaneously. The decay and suffering of Yggdrasil, gnawed by serpents, mirrors the relentless march of entropy in our own universe, the tendency for systems to move toward disorder. Yet the promise of regeneration after Ragnarok offers a profound parallel to cyclical universe models like the conformal cyclic cosmology, where an end can beget a new beginning. Even the roots of the tree connecting the different realms invite speculation about cosmic shortcuts. Could wormholes, theoretical tunnels through space-time, act as these mythical routes, providing hidden pathways between otherwise separate universes? The Norse did not see a perfect, harmonious cosmos. They saw a universe of strife, connection, and inevitable rebirth. Their myth provides a powerful narrative for a modern idea that is otherwise mathematically abstract. Are we living in just one of countless worlds, a single leaf on an infinite ash tree, awaiting its own season of fire and renewal? This very image of a world consumed by flame leads us directly to another primal element of creation. Fire is not merely a destructive power, but a sacred source of creation. For the ancient Zoroastrians, the universe itself was born from a primordial flame. Their supreme deity, Ahura Mazda, was the wise lord who fashioned all of existence from pure, undying light, initiating a great cosmic struggle between order and chaos, truth and falsehood. In their rituals, fire was not just a symbol, it was a living presence, a tangible piece of the divine, and the stars above were distant beacons of this sacred truth, watching over the eternal battle. This dualistic vision, where creation is forged in a celestial conflict, resonates with one of physics' most fundamental mysteries, matter-antimatter asymmetry. In the earliest moments of the universe, for every particle of matter created, there should have been an equal antiparticle of antimatter. Had this perfect symmetry held, they would have annihilated each other completely, leaving behind a universe of pure energy and no substance. Yet we exist. Something broke that symmetry, a cosmic struggle where matter won a slight but decisive victory over its opposite, allowing our material world to form from the ashes of that annihilation. The Zoroastrian fire finds its ultimate expression in the heart of every star. These are not just distant lights, they are immense nuclear furnaces. Through the process of fusion, stars crush hydrogen atoms together under immense pressure and temperature, forging heavier elements like helium, carbon, and oxygen. This is stellar nucleosynthesis, the alchemy that transforms primal fire into the building blocks of complexity. Carl Sagan's famous declaration that we are made of star stuff is a literal chemical truth. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were cooked in the fiery cores of long-dead stars. The most dramatic confirmation of this ancient fiery narrative comes from a star's death. When a massive star exhausts its nuclear fuel, it collapses and then explodes in a supernova, a cataclysm of unimaginable violence. For a brief moment, this single dying star can outshine an entire galaxy. And in that inferno, the remaining elements are forged, from the gold in a wedding ring to the uranium that powers reactors. These explosions then seed the surrounding cosmos with their enriched debris, providing the raw material for new stars, planets, and eventually, life itself. The entire life cycle of a star, from its birth in a glowing nebula to its explosive death, is a story of creation through fire. So how does this illuminate our chemical ancestry? It tells us that the same cosmic fires the Zoroastrians revered as divine are the very same forces that forged our physical bodies. We are not just living in a universe of fire, we are the products of it, a temporary gathering of ancient stardust that once blazed in the heart of a sun. This profound connection between cosmic flame and earthly life brings us back full circle to that grander rhythm, the slow, deep breathing of the universe itself. That timeless state of becoming, where past and present merge into a single reality, finds perhaps its most profound expression in the Aboriginal concept of dreamtime. This is not a distant, finished creation event, but a sacred era of continuous formation, an everyone where ancestral beings walked the earth, singing the world into existence with their journeys. Their paths became rivers, their resting places became mountains, and their deeds became the laws of nature and society. This is a cosmology where creation is never truly over. It is a living process, and the land itself is a sacred text holding the memory of those primordial events. The dreamtime exists outside our linear flow of seconds and years, connecting every moment to that foundational power. Modern physics grapples with this very same strangeness. The block universe theory, supported by Einstein's theory of relativity, proposes that time is a dimension much like space. In this view, the past, present, and future all exist simultaneously, laid out in a vast four-dimensional loaf. We simply experience it slice by slice, moment by moment, like a reader moving through a book. Physicist Julian Barber takes this even further, arguing that time is not a fundamental ingredient of reality at all, but an emergent illusion created by the relationships between changing events. This directly mirrors the dreamtime's everyone, a state where all of existence simply is. The intricate knowledge held within these oral traditions offers stunning validation of this deep connection to the cosmos. Aboriginal cultures meticulously mapped the night sky, not as a separate celestial sphere, but as an extension of the landscape below. The emu in the sky, a dark nebula constellation, is tied to seasonal cycles and earthly emu behavior, creating a unified model of reality where the celestial and the terrestrial are one. This reflects a principle in modern quantum mechanics known as entanglement, where two particles can be instantaneously connected across vast distances, defying our everyday notions of local cause and effect. The entire cosmos in this light appears as an interconnected web, much like the songlines that weave the dreamtime into the very soil. So what if time is not a river flowing in one direction, but a vast, still ocean where every moment floats eternally? This ancient understanding collapses the distance between the act of creation and our present experience, suggesting we are living inside an ongoing, timeless event. This radical perspective on time forces us to reconsider the very nature of order and how a stable cosmos could possibly arise from the formless chaos that so many traditions describe as the beginning. The Anunnaki did not create the world from nothing. They brought order to a world that already was a realm of primal, undifferentiated chaos. In the Sumerian epic of creation, these powerful deities, led by Enlil, god of wind and air, and Enki, god of water and wisdom, did not sing the cosmos into being. They imposed their will upon it, separating the heavens from the earth and establishing the fundamental rules, the divine decrees known as the Me. These were not suggestions, but the immutable laws governing everything from kingship and truth to the very rotation of the stars. The universe, in this view, was not born harmonious. Its order was hard-won, carved from a pre-existing state of turbulent potential by a set of cosmic commandments. This ancient narrative finds a stunningly precise parallel in the story told by our most powerful telescopes. The primordial chaos of the Sumerians mirrors the hot, dense soup of particles that filled the universe immediately after the Big Bang. For hundreds of thousands of years, it was an opaque, seething plasma, a state of near-total disorder where light was trapped, bouncing endlessly between particles. Then a fundamental transition occurred, an event cosmologists call recombination. As the universe expanded and cooled, electrons and protons slowed down enough to combine and form the first neutral atoms. In that moment, the cosmic fog cleared, and light was suddenly set free to travel across the universe. This was the moment the heavens were effectively separated from the earth, the moment the universe became transparent and structured. The laws of physics themselves acted as the Anunnaki's divine decrees, the strict set of rules that dictated how this transition must unfold. The work of Nobel laureate James Peebles on the cosmic microwave background radiation was essentially a decoding of these cosmic laws. By meticulously mapping the faint temperature variations in this afterglow light, he revealed the precise seeds of all future structure. Those tiny fluctuations, those minute differences in density from one patch of sky to another, were the direct result of quantum randomness imprinted on the cosmos during its inflationary birth. They were the last vestiges of the primordial chaos, yet it was the unwavering laws of gravity that acted upon this randomness, pulling matter toward these slightly denser regions over billions of years. The divine decree of gravity transformed random noise into the magnificent cosmic web of galaxies and clusters we observe today. So, how did these myths prefigure our understanding of universal laws? They captured the essential truth that our cosmos is not defined by its initial chaos, but by the profound mathematical order that harnessed that chaos to build a world of breathtaking complexity. From the imposition of divine decrees, we turn to a vision of the cosmos not as a set of rules, but as a beautifully woven tapestry. That same idea of a cosmos governed by a hidden, interwoven order finds a breathtakingly beautiful form in the Navajo creation story. Here, the universe is not built by a solitary god, but woven into being by Spider-Woman, a divine being who sings and spins a web of life, connecting every element of existence into a single, intricate tapestry. This is the Diné understanding of Hojua, a state of perfect harmony and balance where every rock, every person, every star is a vital thread in the cosmic weaving. Nothing stands alone, and every action ripples through the entire web, a profound vision of universal interconnectivity. For generations, this was seen as a powerful spiritual metaphor. Then quantum physics stumbled upon what appears to be its blueprint. The phenomenon of quantum entanglement describes a pair of particles linked in such a way that measuring the property of one, like its spin, instantly determines the property of the other, no matter how far apart they are. This connection, which Einstein famously called spooky action at a distance, defies our everyday understanding of space and separation. The physicist John Bell developed a mathematical test, now known as Bell's inequalities, to prove that these connections are real and not the result of some hidden, local variable. When experiments confirmed Bell's theorem, they validated a universe that is, at its heart, non-local. Particles can be entangled across a room, across a continent, or across the galaxy, behaving as a single, unified system, much like 2 points on Spider-Woman's web that vibrate in unison. This cosmic weaving extends to the very largest scales. The universe appears remarkably similar in every direction we look, a property known as isotropy. This large-scale symmetry is like the repeating, balanced pattern in a finely woven rug, a fundamental harmony woven into the fabric of space-time itself. Some theoretical physicists, like Leonard Susskind, have taken this idea of interconnection even further with the holographic principle. It suggests that all the information describing our three-dimensional reality might be encoded on a two-dimensional surface at its boundary, like a cosmic pattern woven onto a vast, distant sphere. Every event within our universe could be a projection of that information, a thread in a grand holographic tapestry. We can even witness this quantum weaving in laboratory experiments today. Scientists routinely create pairs of entangled photons, particles of light. When one photon's polarization is measured and found to be vertical, its twin, even miles away, will instantly be horizontal. This is not a signal traveling between them. It is a deeper, more fundamental connection, a demonstration that the separateness of objects is, at the quantum level, an illusion. So, is the universe a vast, living tapestry where every thread matters? The Navajo worldview and modern physics converge on a startling possibility, that we are all intrinsically woven into a single, shimmering whole, and that our very existence is part of a pattern far greater than we can see. This concept of information woven into the cosmos raises a profound new question. Where did the first threads of that pattern come from? Within the Jainist vision, the cosmos is a vast field of potential, sown with infinite seeds known as jivas or souls, and Pudgala, the eternal substance of matter. These are not created by a god, but are fundamental, uncreated constituents that combine and recombine across endless cycles of time. In this view, our entire reality, from a floating cloud to a distant galaxy, is a temporary configuration sprouting from the interaction of these simple, timeless elements. It is a universe that builds complexity from the bottom up, an eternal dance of soul and substance without a beginning or end. The sheer scale of this cosmology is breathtaking, describing a universe that is both finite and eternal, a self-assembling system of staggering diversity born from a limited set of primal ingredients. This ancient intuition of a reality bubbling up from a foundational layer finds a startlingly precise echo in the most radical ideas of modern physics. The vacuum of space is not empty. At the smallest imaginable scales, far below the atom, the fabric of spacetime itself is thought to be in a state of constant turbulence. Physicist John Wheeler described this as quantum foam, a seething sea where virtual particles and antiparticles spontaneously pop into and out of existence, creating a frothing, chaotic energy landscape. These fleeting fluctuations are the quantum equivalent of the Jainist seeds, the fundamental units of potential from which everything can emerge. The delicate balance in this quantum realm resonates with the Jain principle of extreme non-violence, or ahimsa. Just as the slightest disturbance can disrupt a fragile ecosystem, the quantum foam exists in a state of perfect dynamic equilibrium. The energy borrowed from the vacuum to create a particle pair must be paid back within an infinitesimally short time, a cosmic balancing act of exquisite precision. We can even witness the tangible effects of this seething vacuum energy. The Casimir effect demonstrates this beautifully. When two uncharged metallic plates are placed extremely close together in a vacuum, they are pushed toward each other by an invisible force. This happens because the quantum fluctuations between the plates are restricted, while those outside the plates are not, creating a pressure difference that nudges them together. It is a direct, measurable force arising from the activity of the quantum foam, a ghostly push from nothingness itself. So, how do these ancient seeds inform our view of fundamental reality? They suggest that the solid, predictable world we experience is a grand illusion, a stable pattern emerging from a deeper, chaotic, and generative foundation. The universe may not have been built from the top down by a creator, but may have grown from the bottom up, sprouting from an eternal field of quantum potential. From this microscopic foam of creation, we shift our gaze to the largest structures in the cosmos, the immense and seemingly empty voids that stretch between the galaxies. The vast cosmic voids between galaxies are not merely empty space, but a profound nothingness that somehow contains everything. This paradox lies at the heart of the ancient Buddhist philosophy of shunyata, a concept of emptiness that is anything but a bleak void. Articulated by the philosopher Nagarjuna, Shunyata teaches that all phenomena, from a thought to a galaxy, are empty of a permanent, independent self. They do not exist in isolation, but only in relation to everything else, born from a vast web of cause and condition known as dependent origination. Reality is a constant, flowing process, as transient and interdependent as clouds forming and dissolving in the sky. The cosmos itself, in this view, does not arise from a solid, eternal substance, but from this foundational, generative emptiness. For centuries, this was a deeply spiritual insight. Now, cosmology provides a startlingly literal interpretation. The vacuum of space is not the passive nothingness of classical physics. Quantum field theory reveals it as a dynamic field simmering with potential energy. So-called virtual particles wink in and out of existence, their fleeting lives governed by the uncertainty principle. This quantum vacuum is unstable, a seething sea of possibility where the rules of cause and effect are blurred. Cosmologist Lawrence Krauss has explored this very idea, suggesting that the laws of quantum mechanics allow for a universe to spontaneously appear from nothing, because nothing, as physics defines it, is profoundly unstable. The parallel to dependent origination is striking. Just as a particle in quantum field theory has no inherent existence without its underlying field, all things in the Buddhist view depend on a vast network of causes for their being. There is no isolated electron, only a momentary manifestation of a quantum field. This finds its grandest expression in the theory of cosmic inflation. Our entire universe, in all its splendor, may be the result of a single, incredibly fortunate quantum fluctuation in that primordial emptiness, a tiny patch of the vacuum, filled with a peculiar inflationary energy, suddenly expanded at a speed far beyond light, smoothing and stretching that initial quantum seed into the vast cosmos we inhabit today. The very emptiness of space, it turns out, is now doing something even more dramatic. Dark energy, the mysterious force driving the accelerated expansion of the universe, appears to be a property of empty space itself. The more the universe expands, the more vacuum is created, and the more powerful this repulsive force becomes. The greatest creative force in the cosmos is emanating from apparent nothingness. So what if emptiness is the ultimate source of all form? This ancient philosophy challenges our most basic assumptions about reality, suggesting that solidity and separation are illusions. The universe is a dance of transient patterns emerging from and returning to a fertile void, a concept that leads us directly to the rigid, perfect shapes the ancients believed underpinned this entire cosmic dance. Plato saw the universe etched in geometry. In his dialogue Timaeus, he proposed a cosmos built not from chaotic matter, but from 5 perfect, symmetrical shapes. These are the Platonic Solids, the only 3-dimensional forms with identical faces meeting at identical angles. He assigned each to a fundamental element. The tetrahedron was the sharp, mobile atom of fire. The stable cube formed the earth, the flowing octahedron was air, and the multifaceted icosahedron represented water. For the heavens themselves, the last shape, the dodecahedron, was used by the god to arrange the constellations, giving the entire cosmos its divine, geometric order. This was more than a poetic metaphor. It was a declaration that mathematics is the hidden language of reality, the perfect blueprint from which our imperfect world is constructed. For centuries, this was seen as beautiful philosophy. Then we began to see these very shapes appearing in nature. The tetrahedron and the cube are fundamental structures in crystal lattices, the atomic architecture of diamonds and salt. The hexagonal patterns of snowflakes and honeycombs are 2-dimensional echoes of this 3-dimensional perfection. The ancients were observing a deep truth, that nature often builds from a limited set of optimal geometric templates. But could this extend to the shape of the universe itself? Modern topology, the branch of mathematics that studies the properties of space, takes this question seriously. One of the leading candidates for the overall shape of the cosmos is a model known as the Poincaré dodecahedral space. This is a finite universe with no boundaries, where if you could travel in a straight line far enough, you would eventually return to your starting point, but the space would be twisted or multiply connected like a cosmic hall of mirrors. The geometry is based on a dodecahedron whose opposite faces are abstractly glued together. The work of mathematician Henri Poincaré on homology laid the groundwork for understanding such strange and beautiful topological shapes. The search for evidence of this geometric code led scientists to the oldest light in the universe, the cosmic microwave background. When the Wilkinson Microwave Anisotropy Probe, or WMAP, mapped this afterglow in exquisite detail, some teams analyzed the data for specific patterns, like matching circles in the sky that would indicate a multiply-connected space. While the evidence remains inconclusive and debated, the fact that such a profound idea can be tested at all is a testament to Plato's original vision. So, could the universe be a kind of crystal, a perfect geometric form existing in a dimension we cannot directly perceive? This ancient theory suggests that the deepest secrets of existence might not be found in particles or forces, but in the timeless, silent language of shape and number. And if the cosmos is fundamentally mathematical, what role does its most fundamental messenger, light itself, play in its ongoing creation? Light was not just the first creation in many myths, it was the very substance of the divine. For the ancient Gnostics, a diverse group of esoteric Christian and Jewish thinkers, the material world we perceive was a flawed and shadowy prison, crafted by an ignorant and flawed creator they called the Demiurge. True reality was something else entirely, a transcendent realm of pure, divine light and spirit known as the Pleroma. This was the fullness of God, an incomprehensible source from which all true being emanated like rays from a hidden sun. The path to salvation was not faith, but gnosis, a direct, intuitive knowledge of this hidden reality, piercing the veil of the material illusion to reconnect with the luminous source of all things. This radical idea that our world is a dim projection of a deeper, brighter reality finds a haunting echo in the physics of our cosmic dawn. Following the Big Bang, the universe entered a phase known as the photon epoch, a time spanning hundreds of thousands of years where light itself was the dominant force. The cosmos was a searing, opaque ocean of plasma, a soup of particles where photons of light were constantly born, scattered, and absorbed, trapped in a relentless dance with matter. There was no darkness, only an all-encompassing, blinding glow. This was the primordial light field, a physical reality that mirrors the Gnostic vision of a universe saturated with divine radiance. The physicist David Bohm offered a modern framework for this layered reality with his theory of the implicate order. He proposed that the world we see, the explicate order, is a visible manifestation of a far deeper, enfolded, and interconnected reality. This underlying implicate order holds the entire cosmos as an unbroken whole, much like the Pleroma, with our perceived separations being an illusion. The evidence for this primordial light is all around us, quite literally. The cosmic microwave background radiation is the cooled, redshifted remnant of that photon epoch. Its incredible uniformity, the same temperature in every direction to within 1 part in 100,000, is the ghostly afterimage of that early, unified state of light. It is the fossil of the fire that once filled the entire cosmos. This light also played a crucial role in forging the very elements of life. During the era of nucleosynthesis, the intense bath of photons governed the nuclear reactions that created the first hydrogen and helium, setting the stage for everything to come. So, how does this ancient light illuminate our cosmic origins? It suggests that the deepest layer of reality may not be solid matter, but a field of luminous information, a cosmic background of potential from which all form temporarily condenses. This concept of a universe spoken into existence from a foundation of light leads directly to another ancient and powerful idea, that the cosmos itself was created with a word. The command that shattered the silence was not a complex formula, but a simple declaration: let there be light. In the Genesis narrative, this divine utterance is the pivotal moment, the first act that carves a luminous reality out of the dark, formless void. It is a creation story centered on the power of the word, where vibration and command become the very instruments of cosmic genesis. Light is not merely the first thing created, it is the fundamental tool of creation itself, bringing order from chaos through its sheer presence. This ancient idea that reality is spoken into being finds a startlingly literal echo in the most radical frontiers of quantum cosmology. The initial state of our universe, the Big Bang singularity, represents a similar point of absolute potential, a void where all the laws of physics as we know them cease to function. From this state of undefined chaos, something had to trigger the transition to a universe of matter, energy, and time. Quantum theory provides a possible mechanism. The primordial vacuum was not a true nothingness, but a seething sea of quantum fluctuations. These random, microscopic vibrations in the fabric of spacetime can be thought of as the universe's first words, the fundamental utterances of energy that, when amplified by a period of hyper-fast inflation, precipitated the entire physical reality we now inhabit. The physicist John Archibald Wheeler crystallized this profound concept with his phrase, "it from bit." He proposed that every particle, every force field, every event in the universe is ultimately based on immaterial bits of information. In this view, the physical world, the it, arises from the answers to yes or no questions, the bits. The cosmos is not a collection of things, but a symphony of information, a cosmic computation whose output is reality itself. We may even be able to hear the echoes of that first great command. The theory of cosmic inflation predicts that the violent expansion of the universe's earliest moments would have generated ripples in spacetime known as primordial gravitational waves. While not yet definitively detected, finding these waves would be like listening to the vibrations from creation itself, the deep, resonant hum of the universe being spoken into existence. So what if the Big Bang was not a silent explosion, but a cosmic chord, a single, resonant frequency that set all of reality vibrating into being? This idea of a universe born from a fundamental, auditory command naturally draws our attention to the delicate and perfect balance that such a vibration would require to create a life-giving cosmos. That perfect balance between light and shadow is captured in the ancient symbol of yin and yang. For Taoist sages, this was not just a design but the fundamental engine of reality, a dynamic dance of opposites that generates and sustains the entire cosmos. Dark and light, female and male, receptive and active, these forces are not at war but in a constant, fluid interplay, each containing the seed of the other within its heart. The I Ching, or Book of Changes, reveals a universe governed by this cyclical transformation, all flowing from the ineffable source they called the Tao, the underlying unity from which all duality springs. This is a cosmos built on relationship where harmony is found not in static perfection, but in the vibrant, ever-shifting balance between complementary powers. The echoes of this ancient wisdom resonate through our most advanced physics. We see it in the profound mystery of matter-antimatter asymmetry. According to all our theories, the Big Bang should have created equal amounts of matter and antimatter, a perfect yin-yang pair that would have annihilated each other into pure energy, leaving behind a universe with no stars, no planets, and no us. But something happened. A tiny 1 in a billion imbalance, known as CP violation, tipped the scales. Matter gained a slight upper hand over its opposite, and that fragile, broken symmetry is the only reason anything material exists. Our universe is a testament to a fundamental imbalance within a deeper duality. The search for a more perfect balance continues with theories like supersymmetry, which proposes that every known particle has a hidden superpartner, a shadow twin that could restore a profound symmetry to the laws of physics. Though these particles remain elusive, the quest itself reflects the Taoist view of a reality built on paired relationships. We can even see this cosmic dance in the largest structures. Dark matter, with its invisible pulling gravity, acts as the stabilizing receptive yin, providing the scaffolding for galaxies to form. Dark energy, the repulsive force accelerating the expansion of space, is the active, expansive yang driving the cosmos apart. They are the modern yin and yang, two opposing yet complementary forces whose eternal tug of war dictates the ultimate fate of everything. So how does this ancient duality define cosmic evolution? It suggests that creation itself is a process of dynamic tension. A cosmic sea saw where the most profound structures, from the smallest particles to the largest galaxies, emerge from the endless creative conversation between opposing principles. This understanding of cosmic balance through motion leads us directly to the precise mechanics that govern the celestial dance itself. Long before telescopes could trace the cosmic web, the poets of the Rigveda sang of Skambha, the cosmic pillar, an invisible axis that supports both the heavens and the earth, permeating every layer of reality. These ancient hymns described a foundational structure that was not made of stone or fire, but of a divine, all-pervading essence that held the universe in a perfect, stable embrace. It was the unseen scaffold upon which the visible world was hung, a single column connecting all realms of existence. This profound intuition of an invisible architecture finds its precise scientific counterpart in the dark matter filaments of modern cosmology. These are the true cosmic pillars, the vast, unseen threads of an unknown substance that weave through the cosmos, forming a gravitational skeleton upon which galaxies are built like luminous dew on a spider's web. The first hint of this hidden framework came from the work of astronomer Fritz Zwicky in the 1930s. While observing the Coma galaxy cluster, he calculated that the visible galaxies were moving far too quickly to be held together by their own gravity. He concluded that some form of dunkel materie, or dark matter, must be providing the missing mass, an unseen glue binding the cluster together. This was the first scientific whisper of the cosmic pillars the Vedic seers had described millennia earlier. We can now map these invisible structures not by seeing the dark matter itself, but by observing how its immense gravity warps the fabric of spacetime. This phenomenon, known as gravitational lensing, acts as a cosmic X-ray vision. When light from a distant galaxy travels toward us, it bends around these massive dark matter filaments, creating distorted, stretched, or multiple images of the background galaxy. By studying these celestial mirages, astronomers can trace the outline of the unseen scaffolding. One of the most compelling pieces of evidence comes from the Bullet Cluster, a spectacular collision of two galaxy clusters. Observations show that the visible matter, the hot gas detected in X-rays, was slowed by the collision and lagged behind. But the maps created through gravitational lensing revealed that the bulk of the mass, the dark matter, had sailed right through the collision unaffected. This proved that dark matter is not only real but forms a separate, dominant framework that guides the cosmos. The ancient Skambha and the dark matter web are one and the same concept, an intuition of the hidden pillars that uphold our reality. What invisible forces, mapped by sages and scientists across the ages, truly hold the stars in their places and give the universe its form? This understanding of a cosmic structure that remembers its own shape leads us to ponder an even deeper question. Could the universe itself possess a kind of memory, a permanent record of everything that has ever happened? the universe whispers its deepest secret in a simple, ancient phrase. As above, so below, this hermetic principle inscribed on the legendary emerald tablet suggests a cosmos of infinite reflection, where the grand design of the galaxy is mirrored in the intricate dance of the atom. It is a vision of a unified reality where the same patterns repeat across every conceivable scale, from the cosmic to the commonplace. This was not merely a spiritual idea, but a precise observation of nature's blueprints, a belief that the laws governing the stars were the very same laws that govern the human soul. For centuries, this seemed like mystical poetry. Then we discovered the mathematics to prove it. The work of mathematician Benoit Mandelbrot gave us fractal geometry, the formal language of these self-similar patterns. A fractal is a shape whose intricate details repeat at smaller and smaller scales, like a coastline that looks just as jagged from a satellite as it does from a foot away. This is not an abstract concept. Look at a head of broccoli and you see its florets are miniature versions of the whole stalk. Watch a bolt of lightning fork across the sky, and you are seeing a fractal pattern of electrical discharge. The Hermetic axiom was a pre-scientific description of a fractal cosmos, and when we point our telescopes at the sky, the evidence is staggering. The distribution of matter in the universe is not random. Vast surveys show that galaxies cluster into groups, which then form larger clusters, which themselves gather into immense superclusters, all arranged along filaments in the cosmic web. This hierarchy of structure, from the smallest dwarf galaxy to the largest wall of galaxies, exhibits a fractal-like property across vast distances. Even more strikingly, the pattern of empty cosmic voids, those immense black bubbles in space, bears an uncanny resemblance to the microscopic structure of a living cell with its vacuoles and membranes. This reflective principle finds its most radical expression in the holographic principle. Some theoretical physicists propose that all the information describing our three-dimensional reality, every star, every person, every event, might be encoded on a two-dimensional surface at the boundary of the universe. Our rich, volumetric existence could be a projection, a cosmic hologram where every part contains the information of the whole, just as a single fragment of a holographic film can reconstruct the entire image. So is the cosmos a vast, recursive hologram, a single pattern echoing itself from the quantum foam to the galactic web. This ancient insight forces us to see a universe of profound interconnection, where the same fundamental rules are written in the large and in the small. If the cosmos is truly a reflection of itself at every scale, could this intricate, self-aware pattern be the signature of a universal mind? A river does not merely flow, it listens. A mountain does not simply exist, it remembers. This is the heart of animism, one of humanity's oldest and most pervasive worldviews, found in indigenous traditions from the Americas to Africa to Australia. Here, the cosmos is not a collection of inert objects but a vibrant community of persons, a living, breathing tapestry where every element, from a trickling stream to a distant star, possesses its own spirit, agency, and inherent consciousness. The universe is not a machine, it is an organism, and we are but one conscious thread woven into its sentient web. This ancient intuition that mind and matter are deeply entwined finds a provocative and growing voice in modern philosophy under the name of panpsychism. Philosophers like David Chalmers have challenged the conventional materialist view, arguing that consciousness cannot be explained away as a mere byproduct of complex computation in the brain. Instead, he and others propose that consciousness is a fundamental property of the universe, as basic as mass or charge. In this view, all matter has some form of inner experience, however simple. An electron may possess only a faint whisper of feeling, a proto-consciousness, but that spark is there, woven into the fabric of reality itself. This perspective radically reframes cosmic evolution. We often describe the universe's growth as a physical process, from simple particles to complex galaxies. But what if it is also a story of awakening? Just as a single cell holds the potential for a complex brain, the fundamental fields of the cosmos, from their inception, contain the potential for rich, integrated consciousness. The fine-tuning of the universe, the inexplicably precise calibration of physical constants that allowed for stars, planets, and life, could be seen not as a lucky accident, but as a feature of a universe inherently oriented toward complexity and awareness. This idea is formalized in frameworks like integrated information theory, which suggests that any system with a sufficient degree of interconnectedness and complexity possesses consciousness. A human brain is one such system, but why could a galaxy, with its billions of stars held in a delicate gravitational dance, not also be considered a vast, slow-thinking mind? The universe is not just building structures, it is weaving a network of sentience, with each level of complexity yielding a different quality of experience. So is the cosmos aware. The animist and panpsychist views suggest that we are not lonely observers in a dead universe, but participants in a grand, conscious communion. We are the universe becoming aware of itself, a thought forming in a mind that is itself everything. This profound sense of a living, conscious cosmos experiencing its own existence through endless cycles brings us to the final, all-encompassing theory of time itself. Deep within the Mayan vision of time, the universe itself has a heartbeat. Their long count calendar was not a mere tool for marking days, but a grand chronometer for cosmic cycles, measuring epochs of nearly 13,000 years known as backtons. The conclusion of one such cycle, which sparked global speculation about the year 2012, was never prophesied as an end, but as a turning point, a moment of profound renewal and transformation. This system, painstakingly refined by priest astronomers who tracked the delicate dance of Venus and the Sun, reflected a core belief that the cosmos itself is reborn at regular, majestic intervals, progressing through distinct world ages, each with its own character and destiny. This ancient intuition of a rhythmic, regenerative cosmos finds a powerful voice in a modern theory known as the oscillatory universe. In this model, the universe avoids a final, cold death or a runaway tear. Instead, the outward flight of expansion eventually halts, reversed by the collective pull of gravity, leading to a great collapse, a big crunch. This collapse does not end in nothingness, but rebounds, triggering a new Big Bang and birthing a fresh universe from the ashes of the old, in an endless, cyclic procession of creation and destruction. The work of physicist Roger Penrose provides a sophisticated mathematical pathway for such a reality. His conformal cyclic cosmology suggests that the infinitely expanded, empty end of one universe can be geometrically reshaped into the hot, dense beginning of the next, creating a continuous chain of eons. The Mayans, in their own way, had aligned their long cycles with the great astronomical rhythm of the precession of the equinoxes, the slow, 26,000-year wobble of Earth's axis that gradually shifts the position of the stars. They saw this celestial clockwork as a fundamental pulse of time. The search for evidence for these cosmic cycles leads scientists to the same ancient light. The cosmic microwave background, the afterglow of our own universe's birth, is scrutinized for anomalous patterns. Penrose and his collaborators have pointed to the existence of faint, concentric circles in this background radiation, regions of unexpectedly uniform temperature, which they interpret as the gravitational shock waves from the collision of supermassive black holes in the eon that preceded our own. These would be the cosmic bruises, the tangible scars left by a previous universe, echoing the Mayan belief in cycles of death and rebirth written in the sky. So, what does this eternal return mean for our ultimate fate? It suggests that our story is not a one-act play with a final curtain, but an endless epic where every ending is merely a prelude to a new beginning, a cosmic cycle of renewal that our ancestors charted long before our telescopes were built. The final piece of our cosmic puzzle lies with the Dogon people of Mali, a culture whose oral traditions hold a stellar secret that defies easy explanation. For countless generations, their priests have spoken of a tiny, incredibly heavy star that orbits the brilliant Sirius, a star they call Potolo. They knew its 50-year orbital period and described it as the smallest and heaviest thing in existence, made of a metal heavier than iron. This is a precise description of Sirius B, a white dwarf star completely invisible to the naked eye, whose existence was only confirmed by Western astronomers in the 19th century with powerful telescopes. How could a people without optical instruments know of a stellar companion whose density is so immense that a single teaspoon of its matter would weigh many tons? Their creation myth deepens the mystery. They say this knowledge was brought to them by the Namo amphibious, fish-like beings who arrived in a great ark from the Sirius system. These cosmic teachers were described as the masters of water and the life-giving force, the organizers of the world who imparted the fundamentals of civilization and the structure of the cosmos. This is not a vague legend, but a detailed cosmological system that accurately maps a complex binary star system. Astronomer Carl Sagan explored the possibility of cultural contamination, suggesting that perhaps Western visitors in the 1920s or 30s might have shared this astronomical knowledge, which was then absorbed into the existing Dogon mythology. Yet, the depth and integration of this knowledge within their culture, recorded by anthropologists like Marcel Grioul and Germain Dieterlen long before Sirius B was a common topic, makes the case for independent, ancient knowledge deeply compelling. The Hubble Space Telescope has since provided stunning confirmation, capturing clear images of the tiny, dense white dwarf next to its brilliant partner, a sight the Dogon described long before our technology could see it. This stellar mystery forces us to ask what other secrets are encoded in the star lore of indigenous cultures around the world. The Dogon tradition, like the 23 we have explored before it, completes a profound tapestry of ancient insight. From the cosmic breath of Hindu seers to the celestial knowledge of a West African tribe, our ancestors were not merely telling stories. They were mapping a reality that our science is only now beginning to verify, reminding us that the universe has been whispering its secrets to us all along. These 24 ancient visions form a single, breathtaking mosaic of human understanding. The Hindu seers who envisioned a breathing cosmos, the Greek philosophers who imagined atoms dancing in the void, the Dogon elders who mapped an invisible star, they were all looking at the same sky and intuiting different facets of a profound, unified truth. Their myths were humanity's first scientific models, built not with equations but with metaphor, poetry, and a deep, observational connection to the natural world. Each story, whether it spoke of a cosmic egg or a woven tapestry, was a piece of a grand puzzle, an attempt to answer the same fundamental questions that drive our most advanced telescopes and particle colliders today. The real magic lies in how these intuitive leaps are now being quantified. The primordial chaos of Tiamat finds its echo in the seething plasma of the early universe. The Pythagorean music of the spheres resonates in the vibrational strings of theoretical physics. The Navajo concept of a woven cosmos is mirrored in the entangled quantum fields that underpin reality. These are not vague parallels. They are specific, testable confirmations that our ancestors were mapping realities we can now measure. The cosmic microwave background is the tangible evidence for the cosmic egg. The gravitational lensing of distant galaxies traces the invisible pillars of Skambha, the dark matter web. This synthesis reveals a powerful truth about knowledge itself. It is not compartmentalized. The insights of an archaeologist deciphering a cuneiform tablet can illuminate the data on an astrophysicist's screen. The oral traditions of an indigenous culture can hold stellar secrets that challenge our historical timelines. This is the value of an interdisciplinary approach, where the humanities and the sciences are not rivals but partners in a shared quest to understand our place in the cosmos. So, how do we continue to learn from the past as we venture toward the stars? We listen. We recognize that the universe has been speaking to us for millennia, not only in the language of mathematics, but in the stories we have told each other around fires for thousands of years. The greatest discovery might not be a new particle or a distant galaxy, but a deeper appreciation for the timeless, intuitive wisdom that has always connected humanity to the cosmos. Our journey through 24 ancient visions reveals a cosmos that has always been speaking to us. These stories, from the cyclical breath of Hindu seers to the quantum seeds of Jainist thought, were not mere fantasies. They were humanity's first scientific models, built on a foundation of deep observation and poetic intuition, and they prefigured discoveries we now quantify with satellites and particle colliders. The primordial chaos of Tiamat finds its form in the seething plasma of the early universe. The Pythagorean music of the spheres resonates in the vibrational strings of theoretical physics. This is not coincidence. It is the enduring power of the human mind to perceive the deep patterns of reality, whether gazing at the stars from a desert plain or analyzing data on a screen. Carl Sagan's beautiful words remind us that the cosmos is within us. We are made of star stuff. This is the ultimate unity of ancient wisdom and contemporary science, a dialogue across millennia that enriches our understanding of where we come from and what we are. Which of these 24 theories resonated most deeply with you? Did the cosmic egg of the Orphic mysteries capture your imagination, or perhaps the living tapestry of the Navajo spider woman? Share your thoughts in the comments below. I am truly curious to hear which connection sparked your sense of wonder. If this exploration expanded your perspective on the universe and our place within it, consider subscribing for more journeys into the heart of space mysteries. Thank you for joining this cosmic dialogue across the ages. May your own curiosity forever reach for the stars.